In this video, we're going to both expand and condense logarithmic expressions by using the properties of logarithms. So before we begin, I just wanted to refresh your memory on the properties of logarithms that we're going to be using. So remember, we have the product property of logarithms, where if we have a product inside of the logarithm, it can be split up into the addition problem of two logarithms with those two items inside being added. The quotient property of logarithms, which means when we have division inside of the logarithm, we can break it up into subtraction of those two items inside of the logarithm. And then the power property of logarithms, where we can bring whatever is in the exponent out in front of the logarithm and make it a coefficient of that logarithm. So these are the three main properties we're going to be utilizing throughout the next few examples. So if you take a look at this example here, what you're going to notice is that we have a single logarithm right now, and it has quite a few of the different properties going on. So we can see that there's multiplication, we can see that there's division, and we can see that there's a power. And our goal here is to be able to expand this logarithm by using the properties that we know into as many single logarithms as we can. So what I like to do first is I like to break this up into the multiplications and divisions, because truly we can't deal with the powers until we get that power into a single logarithm. Now, when I look at this, what I notice is that there is a division with the y. So that tells me that at some point there's going to be a subtraction in front of that logarithm with the y, and that's what results in it being in the denominator. Now up in the numerator, I can see that there's a multiplication going on here, and that multiplication tells me that there's going to be an addition going on, because that's going to be adding of two logs to form that multiplication. So how I'm going to start this process is anything that I see that's up in the numerator, I'm going to have a plus sign in front of, because that's going to signal that I have a multiplication inside of my logarithm. That's in fact putting it on top of that fraction. And then with the y, because it's in the denominator, I'm going to have a subtraction so that it flips it to division. So if I split this up, I'm going to do the natural log of 5. Then I have plus the natural log of x to the power of 7. And then I have a subtraction of the natural log with the y on the inside. So notice here that this subtraction piece is what puts that y into the denominator when we condense these all into one logarithm. So the plus signs are multiplying those values, putting them in the numerator, and then that subtraction sign is indicating a division that's putting the y into the denominator. So we were able to split up the fraction portion of this particular logarithm. Then from here, what we need to do is we need to deal with the power. And we know that we can bring our powers out in front. So I'm going to bring my power out in front here. So as a result, my final answer is going to be the natural log of 5 plus the 7 natural log of x minus the natural log of y. So now we're going to flip things around, and instead of expanding a logarithm out completely, we are going to condense a logarithm down. And so essentially we take the exact opposite approach we had before. So before we broke it up into the pluses and the minuses, and then we dealt with the powers. And now we're going to flip that piece around. So when we need to condense logarithms, we're always going to start by dealing with any powers that need to be pulled out in front of that logarithm. And essentially where we're going to see those is where a logarithm has a coefficient out in front of it. So here I can pull that into my problem. So here the log base 7 of 9 isn't going to change, but now I have log base 7 of, when that 3 goes into the log, it becomes 2 to the power of 3, and then I have minus log base 7 of 3. Now I notice that 2 to the power of 3 is an actual number. That's just 2 times 2 times 2, which is equal to 8. So I'm going to rewrite this right away as log base 7 of 9 plus log base 7 of 8 minus log base 7 of 3. So now the last thing I really need to do here is I need to condense these down so that they form one single logarithm. So I'm going to write log base 7 down here, and I'm going to leave some space to put things on the inside. So really the big thing I have to decide here is what's going in the numerator of my fraction and what is going in the denominator. So typically how I like to break this down is if something has a subtraction in front of it, remember that when you subtract logs, this means division. So if we're subtracting, what that means is that this piece right here is really going into the denominator. So that means that the 3 is going to be divided by something. I mean, it's going to be the division part of something. So that 3 goes into the denominator. Then anything that is positive, okay, because we know that when we add logs, we can condense them down into a single log by multiplying the values. If they are positive logarithms with a positive coefficient, this is going to go up into the numerator and they are going to be multiplied. So here we're going to have 9 times 8. And then from here, it's just a simplifying game. So we have log base 7 of 72 over 3. And then we can condense that down just a little bit further to be log base 7 of 24. So let's take a look at two more expanding problems. So here in this first example, I see a logarithm that doesn't contain a fraction at all. It just contains some multiplication. So I know that if I see multiplication, that I can expand this by adding the logarithms together. So I have log of 3 plus log of x to the power of 4. So because the 3 and the x to the 4th were being multiplied, I can expand them by adding them as two separate logarithms. Then we know that if we see a power, we can bring that power out in front as a coefficient. So here our final answer would then be log of 3 plus 4 log of x. Now looking over at example 2, this one has a few more values involved. So when I look at this problem, what I notice is that I have a really big division here. So what I need to remember about this is that I am dividing 5 by both 12 and x. So what that means is as I split this up into additions and subtractions as separate logarithms, that everything in the denominator is going to have a subtraction in front of it because the 5 is being divided by those values. So I'm anticipating two subtractions, one in front of the x and one in front of the 12. So let's start. We have log base 5 with a 5 on the inside. And then we have minus log base 5 of 12, indicating that the 5 is divided by 12. And then we also have a subtraction of log base 5 of x, because that x is also in the denominator there with 12. So those subtraction symbols indicate that there is a division going on and that those values are ending up in the denominator of the log that we started with. So let's try two more condensing problems here. So here we have log of x minus log of 9. So this is going to become a quotient problem because there is subtraction. So it's going to become log, and then we'll have x divided by 9. First number in the top, second number in the bottom. There's our simplified log. This second problem here, what I notice right off the bat is that I have a coefficient out in front of my natural log. So I know that that is an exponent that I need to pull back inside of the logarithm. So here we have the natural log of 4 plus the natural log of 3 to the power of 5, because I use the power property to pull that back in, and then minus natural log of 12. Now, when I take a look at this, I like to evaluate any numbers that I see right away. So I have 3 to the power of 5, which is 243. So I have natural log of 4 plus the natural log of 243 minus the natural log of 12. So then from here, I notice that I have some additions and subtractions. I know when I see additions that I have that multiplication or that product property. So I know that this, once I pull it inside the log, will turn into multiplication. And then I also know that anytime I see a subtraction, that's indicating that I have the quotient property or division, which means that this value of 12 is going to go into the denominator when I create a single log and have one fraction inside of that single log. So here I'm going to rewrite this as natural log of 4 times 243 over 12. Then from here I'm going to simplify this just a little bit. 243 times the 4 in the numerator gives me 972, which then, when I divide that by 12, leaves me with the natural log of 81.